So what's going to be covered in this video is verify a trigonometric identity by factoring. So in our first example, we have tangent x times cosecant square of x minus tangent of x equal to cotangent of x. So what we're going to do is we're going to work on the left side because it's the most complicated side, and then try to get it to become the same as the right side. So we're going to make the left side become cotangent of x. So in this part, we're going to do some factoring, meaning that you're going to pull out, you're going to factor out, or undistribute a common factor. So here, on the left side, we have two parts. Here's our first part, and then here's our second part. Notice how I said there's two parts because it's being separated by a operation, minus, and the same thing could be said for addition, so plus. So looking at those two parts, the only thing that's in common is tangent of x. So when I'm factoring, and yeah, I'm going to do this step by step. When I'm factoring out, I'm actually undistributing, meaning I'm going to divide by that common factor. So since I'm factoring out, I'm dividing these two parts by the common factor, which is tangent of x. And like I said, it does not disappear, it doesn't go away, it's just simply going to be on the outside of the parenthesis, tangent of x. Tangent of x times cosecant square of x divided by tangent of x would simply be cosecant square of x. And then negative tangent of x divided by positive tangent of x would be negative 1. Alright. Moving forward, I noticed that I have a cosecant square of x minus 1. That one would deal with the Pythagorean identity. So if I were to write it out here, so the Pythagorean identity is cotangent square x plus 1 equal cosecant square x. If I want the 1 to be with the cosecant square of x, I'm going to do the opposite. So minus 1, minus 1. So cotangent square x equal cosecant square of x minus 1. So that means I'm going to switch out cosecant square x minus 1 with a simpler term, cotangent square of x. So tangent of x times, so instead of cosecant square of x minus 1, it would be cotangent square of x. Now looking at this, we still haven't finished getting to becoming a single cotangent of x. So to make our work easier, we're just simply going to convert into sine and cosine. So tangent of x would imply the quotient identity, which is sine of x over cosine of x, and it's multiplying to cotangent square of x. So the quotient for cotangent square of x will be cosine square of x over sine square of x. Next, I'm going to expand cosine square of x and sine square of x, because when we're multiplying with fractions, it's going to multiply straight across. So since we have a common factor on the top and bottom, I want to expand it so it can be easily seen when we're going to simplify it by dividing common factors. So cosine square of x will be simply cosine of x times cosine of x. And then on the bottom, cosine of x from here. And then sine square of x will simply be sine x sine x. Now at this point, that's when we divide common factors. So I see one sine on the top and one sine on the bottom. So I'm going to divide one sine x from the numerator and denominator. And then there's one cosine of x in the numerator and one on the denominator. So one from the top, one from the bottom. So the only thing that's left is cosine of x over sine of x. Now, to make it simpler, we're just going to apply the quotient identity, which will become cotangent of x, which matches with the right side. So that means we're done. We did everything correctly, carefully, so everything should be good. So we're done. Alright, QED, saying that we finished verifying. In our second example, we have sine of x minus sine of x times secant of x, secant square of x minus 1 equal to tangent of x times secant of x. So again, we're going to be working on the left side, trying to make it become tangent of x, secant of x. So even though we are verifying a trig identity by factoring, before I could do anything, to make our work easier, I'm going to take a look at what's inside the parenthesis. I see that there's two parts, secant square of x minus 1, and I'm taking a closer look. I see that the secant is square and there's a 1. So that means we could maybe apply a trig identity. So going back, if you take a closer look at one of the trig identities, the Pythagorean identity, we can use the tangent square of x plus 1 equal secant square of x. Now, in the example, secant square of x and the 1 are together. So what I'm going to do is I'm going to subtract 1 to get rid of it from the left side, and then combine it with the secant square of x on the right side. So it's going to be tangent square of x equal secant square of x minus 1. So I'm going to switch out secant square of x minus 1, which is complicated right now, and then put in a simpler term, a smaller, easier, simpler term, tangent square of x. So at the moment, everything's going to stay the same. So sine of x minus sine of x. So instead of secant square of x minus 1, I'm just going to simply put tangent square of x. Alright. And then there's a little error. This was supposed to be a plus. So the original was sine of x plus sine of x times secant square of x minus 1. Now at the moment we have sine of x plus sine of x times tangent square of x. Alright, once we switch out the complicated secant square of x minus 1 with the simpler term tangent square of x, now we can factor. So there's two parts. Here's the first one, and then here's the second one. As I stated in the previous example, these two parts are separated by the operation plus, including the minus. So what's in common between these two parts, these two terms, is the sine of x. So I'm going to divide, meaning that I'm going to factor out sine of x on both parts, and like I said, it doesn't go away. It will be simply be outside the parenthesis, sine of x. Sine of x divided by sine of x will be just positive 1. Positive sine of x tangent square of x divided by sine of x will be plus tangent square of x. Alright? Then I'm taking a closer look. I notice we have 1 plus tangent of the square root of x. So this is just identical to the Pythagorean identity we just used right here. So at the moment it looks complicated. 1 plus tangent square root of x. So what I'm going to do, I'm going to switch out with a simpler term. Here we have tangent square root of x plus 1, which is identical to 1 plus tangent square root of x. So right now it's a complicated term. I'm going to switch out with the simpler term. So instead of 1 plus tangent square root of x, I'm going to switch it out with secant square root of x. So sine of x will be on the outside, and then on the inside it will be secant square root of x. So at the moment we use the Pythagorean identity, same one twice, using it to switch out with a simpler term. So now we have sine of x times secant square root of x. So that's the same thing as if it was just sine of x secant square root of x. Now, looking at that it's supposed to be tangent of x times secant of x, we're still not done. So what I'm going to do to make our work easier is that I want to convert everything into sine and cosine. So I'm not going to mess with this one because it's already sine. But I want to switch this out using the reciprocal identity. 1 over, now be very careful, this is secant square of x, so this will become 1 over cosine square of x. Now, as I mentioned before, sine of x right now is like a whole number, so I'm just simply going to multiply to the numerator, which will be sine x over cosine square of x. Now you could do it that way, but remember, we would have to factor it out and then split the cosine square of x into 2 cosine of x. Now, again, you can simply multiply sine of x into the numerator, but before we can do that, what I'm actually going to do is split 1 over cosine square of x into 2 fractions. So I'm going to expand the numerator and the denominator. So we're still going to have sine of x on the outside, and then we're going to have 2 fractions. 1 over cosine of x, and then 1 over cosine of x. So basically I expand this fraction into 2 fractions. Now the only time I could do that is if the numerator was 1, because 1 times 1 is 1. Cosine of x times cosine of x becomes cosine square of x, so it's okay to expand. Now the reason I did that is so that, okay, I'm just simply going to multiply this sine of x to the first fraction. So it will be sine of x over cosine of x times 1 over cosine of x. So what it means is, now let's apply some identities. This one, we're going to apply the quotient identity. So sine of x over cosine of x, that's tangent of x. And then 1 over cosine of x, that's the reciprocal identity, which is secant of x. So taking a look at our answer, tangent of x times secant of x, that's the same as the original example, tangent of x times secant of x. So we finish the left side, working it out, applying the Pythagorean identity twice, the exact same one. Expand the fraction 1 over cosine square of x, multiply, and then apply the quotient identity, and then apply the reciprocal identity to get tangent of x times secant of x. So pretty much done. So Q, E, D. So in review to this second example, be very careful, analyze what you have exactly. If you take a closer look at the example here, notice how we work with secant square of x minus 1 using this Pythagorean identity. And then it came back, after we factor out, we had 1 plus tangent square of x. So it's like, is there a way to make this easier? Which, yes, it is. You can use, or should I say reuse, the Pythagorean identity and changing 1 plus tangent square of x into secant square of x. So there are times you might end up using the same Pythagorean identity or the same quotient identity or the same reciprocal identity to make your work easier. So just keep an eye out on what can you do to make the work simpler, and when you're trying to find the answer when it comes to verifying trig identities.